This video we're going to look at the laws of exponents, okay, and we're going to explain them really quickly. This is just an explanation video, so the worksheet and the actual problems that come with it, you'll see them a little bit later on. Okay, but just have a look at this first, just for a quick explanation of how it works. Okay, the first thing, what is a base number? So when you see an expression, an exponent expression, like, for example, write one up here now, we'll do, say we have 3 to the power of 4. Well, in that situation there, the number 4, we all know already, that's called the exponent. Okay? And the number 3 is the base number. Okay? So in this case here, what we always think of, the base number is the number that the power is acting on. So in this case, it's going to be 3 times 3 times 3 times 3. So the power 4 is acting on the number 3. If you have minus 6 to the power of 2, here the base number is 2, and the exponent is 2 and the base number is 6. It's not minus 6 because the 2 is not acting on the minus. Okay, this is not minus 6 times minus 6. This is minus 6 times 6. Also, if you have this one, that there, okay, again, the exponent is always the exponent, we know that. The base number in this case is minus 6, because the squared, the 2, is acting on the minus and the 6 because they're in parentheses. Okay? Of examples of the laws of exponents. So multiply in terms with the same base number. So say, for example, imagine I have 3 to the power of 2 times 3 to the power of 5. Alright, now, I could find out 3 to the power of 2 is 9, 3 to the power of 5 is 243, and I can multiply those things together and get a big answer. But sometimes I want the answer in exponent form, okay? And what that means is, if you have 3 to the power of 2, that's 3 times 3. Okay? And I'm multiplying that by 3 to the power of 5. 1, 2, 3, 4, 5. Okay? So then, so that's the same as 3 times 3 times 3 times 3. Okay, so 1, 2, 3, 4, 5, 6, 7. That's the same as multiplying 3 by 3 by 3 7 times. So it's equals 3 to the power of 7. And this is what we call exponent form. Okay? Why is it called exponent form? Because I'm writing my answer with an exponent in it. Okay, if I ask you to evaluate this would be 3 squared is 9, 3 to the power of 5 is 243, multiply them and you get 2,187 or something. So that would be evaluating. But what I've done here is I've written it in exponent form. Okay, now this only works with numbers which have the same base. For example, if I show you this here, if I give you an example like, say, 3 to the power of 3 times 4 to the power of 2. Okay, if you expand that, that's 3 times 3 times 3 times 4 times 4. Alright? So that is 3 cubed times 4 squared, and it can't be made any simpler than that. Okay, because in the last example, you'll see what we had was, we had 7 3's multiplied by each other, which is 3 to the power of 7. Here we only have 3 3's multiplied together, which is 3 to the power of 3, and 2 4's, 4 to the power of 2. Okay, so you can only combine them into one if the base numbers are the same. Here the base numbers for the first expression is a 3, and for the second expression is a 4. They can't be combined. They have to be just left as they are. Okay, let's move on to the next rule. Dividing terms with the same base number. Okay, so first of all, let's have just a quick recap of something. If you have 3 over 3, that means 3 divided by 3. Okay, fractions mean division, really. And we know that that's equal to 1. Or any number, if you have 8 over 8, it's 1. So any number divided by itself is 1, right? So let's have a look at this here. If we have say 3 to the power of 4 over 3 to the power of 2. That's the same as 3 times 3 times 3 times 3 all over 3 times 3 times 3. Alright? Now, people in the next room going nuts, so ignore that. Right, if you have, look, it's a 3 divided by a 3, that cancels out and it just gives you a 1. Okay, 3 divided by 3 again, it gives you a 1. And then the last one, 3 divided by 3, again it gives you a 1. So what are you going to left with? You're just left with 3 on the top, which is 3 to the power of 1, right? Because all of these are gone. They've all cancelled out. And actually, sorry, that would be the case if that was 3 to the power of 3. I actually wrote 3 to the power of 2. So what you'll do is, basically what happens is when you divide with the same base number, you subtract the exponents. So for example, if I have, we'll go through some of this in class, but if you have 5 to the power of 7 over 5 to the power of 2, okay, that means you're going to have 5 times 5 times 5 times 5 times 5, 7 times on the top, and you're going to have 5 times 5 on the bottom. So the two 5s in the bottom will cancel 1 5 each from the top, and it will leave you with 5 to the power of 5. So the rule is, and don't worry if you're not too sure about that, the rule is, if you're dividing two terms with the same base number, you subtract the exponents. Okay, so 5 to the power of 7 divided by 5 to the power of 2 is 5 to the power of 5. Okay, and I'll just do a quick explanation of that just for people to see. Because 5 to the 7 is, hold on until I get this right, is 5, 2, 3, 4, 5, 6, and I'll put the 7th one at the front here. That's 5 to the power of 7. 5 to the power of 5 on the bottom. Remember I said if I had 5 divided by 5, they just leave you with 1, they cancel each other out. Another 5 divided by 5 leaves you with 1, so they just cancel each other out. How many 5s am I multiplying now? I have 1 times 1. Well, when you're multiplying 1 by a number, it's like not doing, it's like adding 0. It doesn't make any difference. So what do I have left? I have 1, 2, 3, 4, 5 5s that are being multiplied. So 5 to the 5 is my answer. So the 5s on the bottom cancel the 5s on the top. So the rule is, when multiplying two terms with the same base number, you subtract the exponents. Okay, let's move on. Power to a power. I have to say, I think all these things are pretty easy because of the work we've done before, but just let's have a look and see. Right, if you have, say, now we're going to do all these examples with numbers just to explain the rules, but then we're going to do practice problems in videos and worksheets later on so we can see how we can get a little bit more complicated. So, imagine that you have 3 to the power of 3 and you're going to square that. Okay, now this is different. This is not the same as 3 to the power of 3 times 3 to the power of 2, where you would add the exponents. This means 3 to the power of 3 times 3 to the power of 3. 3, not a 2. Okay, and then we said when we're multiplying two terms with the same base number, we add the exponents. So it's 3 to the power of 6. Or you could expand it. You could expand this, which is 3 by 3 by 3, times this, 3 by 3 by 3, and you'll see that you have 6 3's being multiplied. Okay, so what you do when you have an exponent being raised, the power to a power, you multiply the numbers then. So for example, if you have 5 to the power of 2 to the power of 4, well, that means that what does that mean you're going to have? You're going to have 5 by 5, which is 5 squared, 4 times. So how many 5s are you going to be multiplying in total? It's going to be 5 to the power of 8. And we look at y really quickly down here. So look what's inside the parentheses. 5 squared is 5 times 5. How many times are we going to have that? 4 times. 5 times 5 times 5 times 5 times 5 times 5. Okay, so how many 5s are we multiplying together in total? 1, 2, 3, 4, 5, 6, 7, 8. So that's 5 to the power of 8. So the rule here, when you have a term to raise to a power, so like I have just shown you, you multiplied the two powers together. Okay? One, product to a power. This is pretty easy again, I think. But imagine that you have, okay, so you have 3x squared. So this here, this 3x means 3 times x. When you see numbers written together with no signs or anything between them, that means multiplication. We have to get used to that. Okay, so if you multiply that, it's 3x times 3x. Okay, now the way that you multiply, when you have things like this, you multiply the number by the number and the letter by the letter. So I'm going to write it in order. It's 3. Remember, with multiplication, it doesn't matter the order you multiply things in. 3 times x times x. Okay, I'm just arranging them with the 3's together and the x's together. 3 times 3, 9, x times x, x squared. Okay, so by expanding you'll get the right answer, but you can also remember the rule. The rule is that if you have, so we had 3x squared, well, what you can say is that the squared acts on both of them. That's the same as 3 squared x squared, which is 9x squared, like what we got above. Okay? The same. So if you're more comfortable expanding it, you should expand it. But at the same time, you can see that this 2, because of the parentheses, acts on the 3, so it squares the 3, giving you 9. It acts on the x, so it squares the x, giving you x squared. Okay. We're nearly there. Next one, a fraction to a power. We've done this already, so this is very simple. If you have 2/3 to the power of 3, well, we know that that's 2/3 times 2/3. Now I'm using this new notation for multiplication. This is very important, okay? These are beside each other in parentheses. The little dot represents multiplication, and actually I should put the dot just here in the middle. So top by top, 2 by 2 by 2 is 8, bottom by bottom by bottom is 27. And you will also see that what that's the same as, it really just means that the cube acts on the top, so you get 2 cubed, and the cube acts on the bottom as well, 3 cubed. Okay, and then if you multiply it out, it's 2 times 2 times 2, which is 8 over 27. Okay, so the quotient rule means that instead of having to expand it, you can just put 2 cubed over 3 cubed. And that works with any exponent, with any fraction. And finally, negative exponents, really quickly. So we've already done this, but we'll just have a quick review. If you have 2 over 5 to the minus 2, we said before that the negative exponent flips the fraction, so it becomes 5 over 2 squared. And then you just get 25. We do with the previous rule, 25 over 4. Okay? If I have 3 to the power of minus 1, well, how do you flip 3? 3 flipped becomes 1 over 3, and it's 1 over 3 to the power of 1. Okay, because the minus is gone because we flipped it. What if I have x to the minus 2? How do you flip x? You flip it in the exact same way as you flip a real number. Okay, you do 1 over x and squared. So they're the laws of exponents. That video was just a quick, you can just quickly reflect back on that video for laws of exponents problems. And it's just there as an explanation. Some of the things you might not understand, but as you see in class when we get through the process, it should make more sense.